Okay, so we're now starting to look at inequalities. For the Foundation GCSE, we need to understand how to represent inequalities and how to solve inequalities. So, if we think about a car which is driving within the speed limit and x is its speed, we would say x is anything up to 30 miles an hour. So the mathematical way of saying up to 30 miles an hour is this. X is anything less than, or also, if you have a look down here, you've got this equals sign. X is less than or equal to 30 miles per hour. There, you're not speeding. If, on the other hand, x is bigger than 30 miles per hour, notice here there's no equal sign, it's x is actually bigger than 30 miles an hour, then you are speeding. Both of these are examples of inequalities. If it's or equal to, you've got this little equal sign at the bottom. If it's not or equal to, here we've got what's called a strict inequality. So that's a strict inequality, it's not allowed to be equal to each other. So where we start with this is looking at how we can represent these on a number line. So up here I've got the inequality x is greater than 2. So here's 2 on my number line, so I start it at 2 and x is greater, so it's going upwards to the right from 2, and that arrow tells me it goes on forever. Now, because it's greater than, it's a strict inequality. Here, I don't shade in my starting circle. That is for a strict inequality. So, for my next one, here I'm doing x is less than 1. So I start with a circle at 1. It's still a strict inequality. X can't equal 1, so I keep that blank. And it's less than, so it's going down to the left, and that shows me x is less than 1. My third inequality was x is greater than or equal to 0. So here it's no longer a strict inequality, it's allowed to be equal to 0. Because it's allowed to be equal, I need to show that's different. So I'm going to shade that in to show that it can be equal to 0, and again it's greater than or equal, so it's going upwards to the right. For my next one, x is less than or equal to 3. Again, it's not a strict inequality, it's got that or equals, so I'm shading in my circle. Going down to the left because it's less than, and so here my arrow continues forever. For the last two examples, we've got a bar at both ends. That means there's two limits to my inequality. So let's look at what we're seeing here. Here, it's shaded in, so x could equal 0. Then it can be greater than 0. So I know that it's got to be something to do with x is greater than or equal to 0. But rather than having an arrow going on forever, it stops, and the greatest number it can be, and it can actually be that number, is 3. So x is greater than or equal to 0, but x is less than or equal to 3. Now, in questions, it can ask you to provide the integer solutions. When it asks for integer solutions, that means what are the whole numbers that would fit in here? Now, 0 fits, 1 fits, 2 fits, 3 fits, 4 would be outside of this range. So those are my integer solutions. My last one here, I can be at -1, and I'm going up from -1. So I know that x is greater than or equal to -1. It goes all the way up to 2, but notice it does not include 2. So it's got to actually be less than 2. So in my inequality, I've got x is greater than or equal to -1, but x is less than 2. So notice, the common mistake here, when you put in your integer solutions, would be to include the number 2. Notice that circle and that symbol tells me specifically that the number 2 is not included. write those down as some worked examples, and then I'm going to give you some questions to try yourselves. Okay, so here's a bunch of questions about understanding inequality notation. So the first question, what I'd like you to do for each of these images, I would like you to write down what's the inequality represented by each of these. This is the number line up here, so you're trying to say, what does this inequality represent using this kind of notation? For question 2, you're going the opposite way. So take another copy of the same number line, and I want you to draw in a diagram explaining what each of these looks like. For question 3, I just want you to list the whole numbers which satisfy each of those inequalities. Pause the video while you have a go, and then when you're ready we can have a look at solutions. Okay, hopefully we did well on the first couple of questions. On the first one, just make sure that if the arrow is going up to the right, you've got it as a greater than. If the arrow is going to the left, you've got it as a less than. If the circle is not filled in, then it should be a strict inequality. If the circle is filled in, for example here, you've got or equal to. On part 2, I've drawn the answers on here. So here's your x is greater than 3, x is less than 0, x is greater than or equal to 4, x is greater than or equal to minus 2, x is greater than 0 but less than 2, and x is greater than or equal to 0, so that bit's filled in, but less than 1 is here. G was a nonsense question, doesn't make any sense to be greater than minus 3 but less than or equal to minus 4. You can't do that. Your solutions for your integer questions are down here. 3, 4 and 5, 4, 5, 6 and 7, all the numbers from 3 up to 12, minus 5 up to 0, make sure you don't include that 1, and here minus 3 to plus 3, making sure you don't include minus 4 or positive 4. Please give yourself a mark. It's actually going to be out of 21 now, and if you need any more assistance on that, Hegarty clips number 265 to 267. Well done.